Hello, welcome to your lesson on combined probability diagrams. There are two main types of probability diagrams that we will begin with. These two representations are known as Venn diagrams and sample space diagrams. A Venn diagram represents the sample space in a rectangle. Within the rectangle, each event is represented by a set of outcomes in a circle or an oval shape. Here's an example of a Venn diagram. This one does not have the rectangle around it, but again, typically there will be a rectangle around that. This Venn diagram shows characteristics of whales and fish, and this overlap here are characteristics of both whales and fish. A sample space diagram is another useful way to represent a sample space. It often takes the form of a table. For example, we have this one. Let's say you roll a 4-sided die and a 6-sided die. You want to represent the results of adding the results of the sides rolled. So here is your 4-sided die, here is your 6-sided die, and the results, for example, if you rolled a 1 and a 1, you have a 2 is the sum, or a 2 and a 3 will give a sum of 5. So this sample space diagram gives all the possible sums for rolling those two dice. And again, you can see it's two-dimensional, therefore it's representing two things happening at once. And this one also is representing two things perhaps happening at once. So that's why these are often called combined probability diagrams, because they show the combined probabilities of two things. Alright, let's start with a classic example. We have a deck of cards. A normal deck of cards has 13 cards of 4 suits. One suit is called the hearts, then we have the clubs, diamonds, and spades. The 13 cards begin at an ace, and then we have 2 to 10, and then the face cards, the jack, queen, and king. Let's look at this deck of cards here. We draw one card randomly from the pack, and what is the probability it is an ace or a king? Let's take a look. So here's 4 aces out of 52. And here's 4 kings out of 52 cards. So when we say ace or king, we're saying if you draw a card, what's the chance that you'll get either an ace or a king? That is 4 out of 52 aces plus 4 out of 52 kings, and the total probability is 8 out of 52, which can be reduced to 2 out of 13. Okay, another example, or looking at the same one in a Venn diagram. So let's say we had to represent that in a Venn diagram. Well, as we saw, a Venn diagram begins with a rectangle. Here the U represents the universal set, so it means the entire sample space we're working with, which is a deck of 52 cards. Then we have our aces, and there are 4 of them. Then we have our kings, and there are 4 of them as well. Notice these two circles do not overlap because a card cannot be an ace and a king at the same time. Out here we have 44 remaining cards. So when we have to find the probability of ace or king, we say probability of ace or king, 4 plus 4 is 8 out of 52, which is what we had before. Let's look at a deck of cards again, but now a different question. The probability that the card we draw is a queen or a diamond. So here's our queens, there are 4 of them. Here are our diamonds, there's 13 of them. In this case, it's different than last time because we actually have an overlap. There's one card that is both a queen and a diamond at the same time. So if we were to find this probability, we could say 4 out of 52 is the 4 queens out of 52 plus the 13 diamonds out of 52. However, now we have to subtract 1 because there's that overlapping one. And by adding 4 plus 13, we have counted this card twice. So now we're subtracting away that double counting, and the total we get is 16 out of 52. If you added up all these here, plus these 3, that would be your 16. And that reduces to 4 out of 13. Think about this carefully and make sure you understand that subtraction of the overlap. This is kind of a big idea in probability. So let's look at that in a Venn diagram now as well. So here is your rectangle to begin the Venn diagram. Our universal set is the whole deck of 52 cards. Here we have the queens, and there are 4 of them. Notice I wrote the 4 here along the edge instead of inside the circle. And here we have the diamonds, and there's 13. I wrote it out here as well instead of in here. The reason is when you have overlapping circles in a Venn diagram, you don't want to put the number inside because then it is unclear whether that number represents the entire circle or just this portion. So if we're talking about the entire circle, we put the number on the edge. Okay, we know there's one overlapping card. That is the Queen of Diamonds. It is the card that is both a queen and a diamond at the same time, and there's only one. Now that we know there's 4 queens and one of them is here, there must be 3 queens remaining here, and there's our total of 4. And over here, we have 12 more cards that are diamonds. So when we were asked to find the probability of a queen or a diamond, we were looking for a card that is just a queen or just a diamond, or actually the Queen of Diamonds is okay also. So when we say queen or diamond, we mean queens or diamonds, or actually the card that is both of them as well. If you add up these 3 numbers, you will get 16, which matches what we had here. So again, add up these 3, you get 16, or add these 2, 17, and you subtract the overlap to get the total here. Okay, try one now. So read this situation, draw a Venn diagram in your notes, and see if you can find the probability of event A, probability of event B, and then probability of A union B. We'll talk about this symbol later, but union just means or, so A or B. Okay, I hope you set up your Venn diagram like this. Here we have the probability, the rolling a 1 or a 2. Here's rolling a 5, and the other numbers are 3, 4, and 6, which we're not using here. Event A is just 1, 2, and event B is rolling a 5. So now probability of probability of event A, which is rolling a 1 or 2, is 2 out of 6 possible rolls. Probability of event B, which is just rolling a 5, is 1 out of 6. That is 1 roll out of the possible 6. Probability of A union, or A or B, means what's the probability of this happening or the probability of this happening. And the probability of this or this is actually 3 out of the total 6. So 3 out of 6. Okay, take a look at the second one. See if you can draw that Venn diagram and then find these probabilities. In this case, we see a different symbol here. This one was union. This one is called intersection, and it means the probability of both things happening at the same time. Okay, here's our Venn diagram. Here we have event A, which is rolling a 1 or a 2. Here is event B, which is rolling an even number. Notice that there's an overlap now because that 2 is both either a 1 or 2, or it's part of event B as well, which is even numbers, and the even numbers are 2, 4, and 6. So there's an overlap now. So probability of event A of rolling a 1 or 2, here's the remaining rolls that do not fall into either category. So 2 out of 6 is event A. 3 out of 6 is event B because it's these 3 here. And the probability of A and B occurring at the same time is only this one here. That overlap is the intersection, and that is 1 out of 6. And here we have union again, which means A or B happening. That means either this or both of them, so anything in set A or B. And in that case, there's 4 of those, 4 out of 6. These are a couple key ideas in probability. We'll look at them more later, but this is your first introduction to them. Okay, try this one. Read the problem and see if you can draw this Venn diagram in your notebook, putting the people's names in the correct places. So now ask, what names are in this circle here? Next question, what names fall in here? And last question, what names fall in this zone right here? So let's check. That's what you should have had. I didn't ask about a few zones. I didn't ask about this one, so check that, and I didn't ask out here either. So see if you read this correctly and then put everything in its right place. As you can see, it can get kind of tedious writing out all the elements in the sets. So actually, more often than not, you will see this. Typically, Venn diagrams will be represented like this, where instead of writing all the elements and listing them, you just write how many there are. So there's 2 things in there, 3 elements in here, there's only 1 there, 3 here, and so on. With those numbers, we can get all the probabilities we need. Make sure you have this Venn diagram drawn. We will use it in the next question. So here's this question. Please find these probabilities using that diagram from the last question. Okay, let's check your work. Here's those probabilities. Check the numbers carefully to make sure you understand what happened there. But just to give one as an example, probability a student chosen randomly studies ESS, that is this entire zone here. To get that probability, you take all those students, that one, that one, that one, those numbers, there's 6 of them in total out of 11 total students. And then ESS but not Spanish, ESS but not Spanish. Spanish is here, so that's all these remaining 4 here. Alright, and studies all 3. There's nobody who studies all 3. So 0 probability. And studies exactly 2. Well, find those numbers there. 3 out of 11 is the answer. Let's look at the next question. Okay, so here we have 26 students, 15 taking chemistry, 13 taking biology. So here's 15 chemistry, 13 biology. And it says in this situation, all are taking one of these 2 science classes. What this tells us is that there's how many students here outside of the chemistry and biology students? Well, the answer is 0, because our universal set, our whole group of students is 26, and we know all are taking these 2 classes, so there's 0 out here taking none. Now notice what happens when you do 15 chemistry students plus 13. You get a number bigger than the total group of students. That number will then reveal to you that there must be an overlap. You're counting too much. So what number do you think goes in here? Well, that number is 2, because again, when we added these 2, they make 28, and that exceeds the total we know there is by 2, so there must be an overlap of 2. Now that we know the overlap of 2, we can get this number. So what is it? Well, it must be 13, because 15 is the total there. And what is this number? That must be 11, because we have a 13 total there. Let's change this scenario a little bit. Same group of students. However, now 5 students are not taking either of the 2 science classes. So again, we have our biology, our chemistry, and now what number goes out here? Well, that is now 5, because there's 5 taking neither of the sciences. So now we have 26. 5 are not taking the sciences. So what should be the total within these 2 circles? Well, that total should be 21, because there's 26 in total, 5 here, so there should be 21 students in here, somewhere in bio and chemistry. And again, now we have 13 and 15, so what does that tell you about this number here? Well, that number must be 7, because 26 minus 5 is 21 remaining here. And again, these add up to 28, but there must only be 21, so there's a 7 there. That tells us this is 6 to make 13, and this is 8 to make 15. Try this example now that you've seen the last one. See if you can find these probabilities, but begin with the Venn diagram. Here's the Venn diagram and the probability that's been asked for. Check your work carefully. Another question here. Take a look at this. Alright, so what we did here is you can create a sample space diagram. Here is for the roll of one of the dice, the roll of the other dice, and here's all the sums. I'm sorry, that was the sample space diagram for a typical 6-sided die and another 6-sided die. So notice when you roll 6 and 6, you get 12, and so on. Here's the same diagram created for these 2 dice. Your job is to confirm that probabilities are the same. So here's the confirmation of all those probabilities. Please pause the video and check the work now. This is an important one to study on your own. And the last question we have here is, can you create a sample space diagram for the previous problem and find these probabilities? So here's the sample space diagram. Can you find these probabilities? go ahead and check your work there. Okay, these problems moved quickly at the end. I hope you're pausing and checking as we went. The practice assignment is quite long. Please study hard. You can do it.